Um, microscope out. What's a microscope out again?
It's a tool to measure the very small length. Micrometer, micrometer gauge. Not the
okay,
length. Wait. Yeah, this thing.
The
Yeah,
yes.
microscope gauge.
Mm.
Okay, so it is used to measure very small distance, small length.
Mm. Yes.
A man stands next to a railway track, traveling at 40 meters per second. Takes 2 seconds to pass the man. What's the length of the train? The speed and time. Multiplying them.
80.
Yeah, 80. With quantity equal to acceleration.
The gradient of the speed time graph.
Yes, exactly. Wait, gradient.
Okay.
On the moon, all objects fall with the same acceleration. Which statement explains this?
I think it's D.
No, it is C.
Oh, wait, no. Oh.
The wave on object is proportional to the mass multiplied with the free fall acceleration, the field strength. On the moon, the field strength is about 1/6 of the field strength on Earth. Okay.
Okay.
Gravitational field strength on the moon. Here, 1.6 compared to Earth. Is about 1/6. Okay, it's about 1/6, and its value is about 1.6. 1.6. Okay. So
do I need to know that for my test?
No, you don't need to remember the specific value like that. But a little bit more explanation about this, because the weight is proportional to the field strength G, which has another name, the free fall acceleration. And according to Newton's second law, the acceleration is the ratio of force and mass. Therefore, you have the weight mg divided mass, and therefore the acceleration is g for all objects when there is no friction, air friction. Okay. Measuring cylinder contains 30 centimeter cube of a liquid. Put on a balance. Some more of the liquids added until the liquid level reaches 50 centimeter cube mark. The reading of the balance increases by 30 grams. What is the density? Increases by this, reaches 50. So the increase of the liquid volume, delta V, is 50 minus initial value here, which is 30, huh? Meaning the volume increases by 20 centimeter cubed, and the mass of that increase in the volume is 30 gram. So the density is the mass here, 30 gram, huh? Divide that increase in volume, 20.
Yes.
So that 1.5 gram per centimeter cube. You got it? Increase.
Yes.
Okay. An object moves at constant speed around a circular path. Which statement is correct?
C.
C. Resultant force acts on the object toward the center. Yeah, it seems to be correct. Let me check others. Resultant force acts on the object outward. Wrong. Resultant force acts on the object in direction traveling. Wrong. There is no resultant force. Wrong. So that absolutely C. Well done. A beam of it pivoted at one end here. The distance here 40 centimeter. The weight is 6 newtons. Another force 4 newtons applied to the beam, causing it to balance horizontally. In which direction and where the force is applied?
2 times 6.
Which direction force? Downward, upwards. We can increase the probability to answer it correctly by 50%.
I think. It's. Wait. No. It's the left of. Oh wait, no.
The 6 Newton force, the weight, will generate a moment in the clockwise direction.
Yes.
Clockwise direction moment. So we need another anti-clockwise moment to cancel out this clockwise moment. So the force must be upwards.
Upwards.
Yeah.
Yes.
It could be on the right or on the left, and we can do some calculation to find its value.
Yes. Okay. So
it must be upward. Therefore, we can eliminate the other two options.
I think it's the right to X.
The force is 4 Newton. We have the clockwise torque. The clockwise moment is 6 Newton multiplied with 40 centimeter. Okay, and it must be equal to a anti-clockwise moment. Meaning the anti-clockwise moment must be 4 Newton, the force multiplied with the distance x that we need to find. Okay, so we solve for x from this equation simply. 40 divided 4, that's 10. 10 times 6, 60. But there's no option 60, huh? Oh, 60, meaning it is here. So that the distance here from the middle point to that position is 20 centimeter. So that the total distance from that position where the force acts, the force 4 Newton here, to the pivot, the total distance to the pivot is 60 centimeter, which is the distance x. 60 centimeter there. So the answer is upward and at 20 centimeter to the left of x, to the right, yeah.
Yes.
60 centimeter in this calculation is distance to the pivot. We need an anti-clockwise torque. Question 8. The diagram shows two forces acting on right angle to each other. What the resultant forces? Right angle. Resultant force is drawn as a diagonal of this rectangle, Yeah. And its magnitude is 3 and 4.
I think 5.
Yes, exactly.
Easy.
You have a right triangle, 3, 4, and the other side is 5. This is like a golden ratio, So when we see it a few times, we will remember without calculation. Yeah. 3, 4, 5. Or 6, 8, 9. The ratio. This statement describes the impulse acting on an object. What is impulse?
Like heartbeat?
The force multiplied with the time that the force acts on the object. Which is equal to the change in momentum of the object or the system. Let's open the formula booklet if it is given that equation in the booklet. Was it here? Yeah, formula list, impulse, here.
Oh, we haven't done that yet, I think.
Okay. But you told me there is momentum in the test.
Oh, yes.
Yeah. So impulse equal to the change in momentum. Have you got this formula list?
Mm.
It is in case you need it.
Thank you. Yes.
Okay. The impulse is equal to the change in momentum. Okay. Rate of change force acting the object, the rate of change momentum object. Impulse is the change in momentum.
Okay.
Question 10. A ball mass 0.6 kilogram moving forward at a speed of 5 meters per second. A second ball of mass 0.1 kilogram stationary. The first ball strikes the second ball. The second ball moves forward at a speed of 0.5 meters per second, meaning the same speed. The same speed. The second ball is lighter than the first ball, and therefore it will not receive all the momentum of the first ball, but a part of it. The first ball will keep moving in the initial direction, but the speed of the first ball after collision. Okay, try solving this problem for 2 minutes, and then I help if you cannot solve this problem.
Oh, okay.
Write the equation of the conservation momentum. The sum of the initial momentum of the two balls will be the same as the sum of their momentum after collision.
I think. Oh no. Oh wait, no. I don't know. Never mind.
You know how to do it? Momentum
maybe.
before collision, okay? Before collision must be equal to the total momentum after collision. Okay. Before collision, the momentum of the first ball is 0.16 kilogram multiplied with its speed 0.5 meter per second. Okay, and the second ball initially stationary, and therefore the momentum of the second ball is initially 0. Then after collision, the second ball has the momentum of 0.1 kilogram multiplied with the speed of 0.5 meter per second. The speed here, 0.5 meter per second, is in the same direction as the initial speed, 0.5 of the first ball, and therefore they are both positive and positive. Okay, if one ball has a velocity in the opposite direction, for example, one ball is moving to the right, the other ball is moving to the left, then one velocity is chosen to be positive and the other is negative. Okay, but in this case, the two balls are moving in the same direction after collision. Okay, this is before collision, one ball stationary. After collision, the first ball move with a little speed, and the second ball move with the other speed and velocity in the same direction. Therefore, they're both positive. Okay, and we are asked to calculate the velocity of the first ball after collision. The mass of it is 0.16 kilogram multiplied with that speed after collision, v1 dash. Okay, And so we solve this equation to find V1. And it cannot be the same as the initial speed. It must be less. Therefore, we will eliminate this one. And also eliminate 0 because its mass is greater than the mass of the second ball, and therefore its speed cannot become 0. It can only become 0 if the mass is the same. I show you a video about the experiment of the exchanging momentum, meaning the momentum of one object is totally transferred to the second object, and the first object becomes stationary. So we can eliminate these two options and increase the probability to 50%. Solving this, and I guess that the answer is this one without calculator. But to use a calculator, check that. Okay. So to find the velocity here, we take this product and subtract this thing and then divide this one, right? 0.016, 0.116 times 0.5. And then subtract the other one, which is 0.05, right? 0.1 times 0.5, and then divide 0.16. There. V1 is 0.1875. 0.1875, and therefore it is round to this one. So I guessed correctly.
Yes.
So I see that we need to practice more about this momentum conservation. Yeah. And here some experiment to prove that the momentum conservation to identical cards. Here.
Today we're going to demonstrate
the two cards here, they may identically, meaning they have almost the same mass, okay, and the same shape. They are placed on a perfectly horizontal track, aluminum track, which has very low friction, and their tiny wheel can smoothly rotate and move on the track. We place one card at one position and use our hand, of course, to push another card toward the stationary card. Okay. There. This is the part I'm looking for. One card is pushed to move. There, and become almost stationary because all of its momentum, mass times velocity, all of its momentum has transferred totally 100% to the other card, and the first card becomes stationary, and the second card move with the same momentum as the first card, and therefore the same velocity because their masses are the same. Okay.
Yes.
It is the same as the Newton's cradle. Have you seen it? This is a very famous toy that many teachers use to demonstrate the conservation of momentum, because these balls are identical in mass, so the momentum from one ball can transfer totally 100% through all the balls to the other ball on the other side. Okay. So the momentum, the velocity of an object only can become 0 when their masses are the same. Okay, but not the same in this case. Question 11. Tennis ball drop from position 1. It falls vertically onto the hard surface at position 2. Which energy changes have taken place between position 1 and 2?
B.
B. Potential kinetic elastic strain.
But this topic we learned in school very recently, but he told us that this won't be in the test.
Okay.
So energy won't be. Yes.
Okay. Anyway, it is elastic strain. You took correctly. A boy holds on to a bar and pulls himself up until his chin is level with the bar. It raises himself through 40 centimeters in 0.5 seconds. The weight is 500 newtons. What is the average power he produces as he raises himself? The test involve power? Not energy interval,
No.
probably not, not power.
Not yet.
Diagram shows the deep reservoir from by dam. On what does the pressure X depend?
Oh, we didn't do pressure yet too.
Okay, it depends on the depth. The condition of
okay.
the sample of gas changes in two stages. Probably you don't test this, right? Gas?
Yeah.
Okay.
Mm.
Liquid. Can you please type here the topics, the topic in the test?
Oh. Okay. I need to check. My Wi-Fi. 1 second. Oh, I accidentally clicked enter. There's more than that. Oops.
Oh, motion, yeah, very important topic. Mass and weight. Density.
Force.
Mainly mechanics.
Yes.
Up to momentum.
Oh. Yes. Momentum.
General physics here. The general this is the general physics part. Include density, work, power, forces, Hooke's law, length, motion. That about the topic 1, general physics. Okay, moving on. We skip the thermophysics part. Skip it.
Next.
One in copper bar heated. Thermal. Water, surface. On about thermal. So the first 15 questions is about mechanics. Those next things down here is about thermal, wave, electricity, etc. So we're almost done with the mechanic part in the first 15 questions. Okay?
Yes.
Okay. Do you have a test of paper 1 or paper 4?
Only 246.
246. Okay, 246. Yes. So let's do paper 4 now.
Yes.
Where is it? Here. 4.2 masking. Looking for 4.2. Here, question paper. Masking. Download is fine. 4.2. And the masking. Okay, 4.2. Electrical powered bicycle. We haven't learned electricity, so we skip it.
Yeah.
Object, mass 2 kg on a bench. This object is connected by cord passing over a pulley to an object of mass 3 kg down here. The 2 kg object on the table is released from rest and accelerates at 4 meters per second square. calculate the resultant force acting on the 2 kilogram object.
Okay.
Question is resultant force. We are given acceleration and mass. The famous equation is
FMA.
yeah, F equal ma. Yeah.
Yes.
2 kilogram multiplied with 4, so the force is 8 newtons. Calculate the upward force exerted on by the cord on the 3 kilogram object. Upward force meaning the tension.
Is it
3 kilogram object. Okay. Of course, this 3 kilogram object has the same acceleration as the 2 kilogram object, but in different direction downwards. Okay. The 2 kilogram object is moved to the left, and the 3 kilogram object falls down, but with the same magnitude of acceleration, which is 4 meters per second square. And to find the upward force, meaning this force F, we need to use the net force. The net force on this object is the difference between the weight and that upward force. The weight must be greater than the upward force, so that the net force is downward, and to accelerate this object downward. Okay, and therefore, firstly, we need to calculate the resultant force on that 3 kilogram object, which is F dash equal the mass of it, 3 kilogram, multiplied with the acceleration 4 newtons, that is 12 newtons. Sorry, acceleration meter per second square unit. This force, the net force, is the difference of the weight and upward force, and therefore the upward force is the weight, which is 3 times, I don't know if you are allowed to use 10 or 9.8, but in case 9.8 is always better, and then subtract the net force, which is 12. So 3 times 9.8, and then subtract 12. The upward force is 17.4, and if we round to two significant figures, it is 17 newtons.
Yes.
Okay. This force can be also called net force. We use a dash here to distinguish the two forces. The objects have constant acceleration. Show that the speed of the object 0.8 seconds after release is 3.2 meters per second. The speed is calculated by
distance over time.
No, that equation is only applicable, can be applied for an object moving with a constant speed. But in this case, it accelerates. It accelerates. You have the equation of acceleration. You have acceleration is the final velocity, subtract initial velocity, and divide the time. And therefore, you can deduce for the velocity to be acceleration multiplied with time and added with the initial velocity. Acceleration multiplied with time is the change or the increase in velocity. Change in velocity during that time period, t. Okay, and u here is the initial velocity. It's not very difficult to remember from the equation of the acceleration, or you can look for the equation. No. Okay, here it is. Acceleration. Yeah. Acceleration, final velocity minus initial velocity, and divide the time. Okay. So initial velocity at rest, of course, this is 0. The acceleration is 4 meters per second square. Yeah. 4. And multiply with the time 0.8 second, we will get 3.2 easily, 3.2 meter per second. Of course, you don't need to write this equation in the answer. Okay, just write this
yes.
one. 2 mark, 1 mark for the correct equation, and 1 mark for the correct flocking.
Mm.
Next question 2. A cart of width 2 centimeter fixed to 1 kilogram object. Here.
Yes.
As the 2 kilogram object moves to the left, the cart passes through a beam of light that is perpendicular to the cart. Using the speed given in C1, calculate the time taken for the cart to pass through the beam of light. The width or the length is only 2 centimeter. The time, the speed, as it moves to the left, but the speed increases. The speed is not constant. So I'm thinking if we can use speed 0.2 meter per second or another value, because the speed is not constant. Pass through the beam of light. They didn't mention that at what time, which is the 0.8 second after release. But the only way to do that, we have to use speed. So that time is the length of the cart, which is 2 centimeter. 2 centimeter is 0.02 meter divided with speed 3.2. We get a very short time.
Yes.
And let me check with the answer, because I'm not sure which speed should we use. That is question number 2. 2C2. Here. Yeah. Exactly the same way. 6.3 times 10 to the negative 3 seconds.
Yes.
6.3 times 10 to the negative 3 seconds. Because the length of the cart is very small, only 2 centimeters, and therefore we can take a value velocity to calculate the time. Because if the length is very long, then the velocity will vary with time as it moves. Okay, therefore the time cannot be calculated by this simple equation, but it is over your current level IGCSE course. Okay. The time. Question 3. The water in a river moving parallel to the river bank at 4 meters per second and canal traveling in the river. The angle, the canal, the velocity relative to water.
Yes.
Water moving at this. The canal travel, the angle. Draw the scale diagram. Determine the canal resultant velocity and state the scale you use. So for 2.5 meters per second, but it is very important to understand what it means by relative to the water moving 4 meters per second. Okay, 4 meters per second, you can draw like 4 centimeter. Each centimeter represent 1 meter per second. Represents 1 meter per second, and then the velocity of the canal compared to the river, to the water, 2.5 centimeter, making an angle of 38 degrees. 2.5. If we use some notation, the velocity of the water is v1 10, where 0 represents the bank, Okay, 1 represents the water. The velocity of the candle compared to the water is v21. v21.
Oh.
We want to find the velocity of the candle compared to the bank, v20. 2 is the candle, 0 is the bank. Okay, v20 will be equal to v21 plus v10. It is like AB equal AC plus CB. Okay, C is the connection. AC equal AB plus BC, B the connection. So here 1 and 1 is the connection. Okay, meaning the velocity of the candle to the bank will be the sum of the velocity of the candle relative to the water and add it with the velocity of the water, meaning we adding to these two vectors to find the resultant velocity. So this is the resultant velocity of the candle compared to the bank. Okay, resultant velocity VR. With the correct scale 4 centimeter and 2 centimeter, you then can use a ruler to measure the length of its resultant velocity. Have you done it? And of course,
Yes.
Yeah, and of course, you protractor to make sure that this is 38 degrees. Once I help a student to use a application to find that resultant velocity, so here it is.
Okay.
Copy the link. So using this software, it will be faster than drawing on the paper. I want one vector to be okay. One vector, the blue vector, where is it? Angle here. Okay. The orange vector here is the velocity of the water. Okay, orange, and I want to make its length to be 4. Okay, 40 represent 4 meters per second. Okay. The second vector, the candle, I want to make the angle of 38 degrees. So 38 degrees means, the angle from this horizontal exit in the anti-clockwise direction to here is 180 degrees minus 38 degree, 180 minus 38, 142. Okay, this angle is 142 there. The blue vector is the velocity of the candle, and I will reduce it to 25. Okay, 25. And this is the black vector here is the resultant velocity. The black vector, which is 25.48. Do you have the same result or on your drawing on your notebook? Meaning the resultant velocity is 2.5 meters per second.
Yes.
2.5 meters per second, 2.5 centimeter, right? Let me check the marks here. 2.5 here. Wait. Correctly drawn. No. Resultant velocity, the magnitude, it is like from 2.3 to 2.8 inclusive. What does it mean by inclusive? Inclusive. Including or covering all the services, facility, not excluding any other parties or group involved in something. Okay, so you are allowed to make a huge mistake within this range. Direction from 35 to 40 degrees, and it is 37, which is in this range. Okay, downstream.
Yes.
Downstream. Okay, so the answer using the scale, your ruler to measure this length, the scale is mentioned here.
Mhm.
The magnitude of the resultant velocity, according to this software, is 2.55, or we can just round to 2.4. Wait, 2.5. 2.5 meter per second, two significant figure, and the angle from the river bank, meaning this angle is 37 degrees. 37 degrees.
Wait, in this case scenario, are we allowed to use like tangent or cosine or sine?
Yes, you can do that. You can use that. There's a rule called cosine rule for a triangle, you know.
Oh yeah,
For
yeah.
a triangle, let's call this is A. This is let me change the color. This is A. This is B. This is C. So we're calculating A. A square is equal to B square plus C square minus two times of B and C, and cosine the angle between those sides B and C, which is 38 degrees, and then you can calculate A. But that's a lot more longer than just use the ruler and measure the scale and the length of this vector. 1 centimeter represents 1 meter per second. So if you measure this length to be 2.5 centimeter, it means 2.5 meter per second for the speed. Yeah, and use the protractor, draw it accurately, and then you can quickly determine the resultant velocity without too much calculation like this.
Yes.
Here 38, sorry, not 30.
Ah.
The mass of the canoeist is 65 kilograms. Calculate her kinetic energy when traveling in still water at 2.5 meters per second. Very simple, huh? Kinetic energy, 1/2 mv square. 1/2 her mass, 65 kilograms, multiplied with 2.5 squared. To be quick, 200 joules. 200 joules.
Wait. Oh, yeah. Is that energy?
Yes. The question here, kinetic energy, 1/2 mv squared. M is 65, v squared 2.5 squared, and then divide 2. Yeah. The result a little bit greater than 200, but we are supposed to round to the most two significant figures, huh? And so the only way is 200.
Yes.
200 joules. We're not allowed to use more significant figure than the given value, huh? Multiplication, so there's two significant figures, 1, 2. Okay. So this is about vector addition, nothing about motion. Okay, question 4. State and explain two features of liquid in glass thermometer. Ignore that, skip. Sound wave, skip. Light refraction, skip. Magnet, no. Only one question about the mechanics like that, huh? Electric circuit, okay. Alpha particle, moving forward, Folgoy, okay. Okay, done. That is only one question, two questions about, motion, Newton's law here.
Yes.
Should we do paper 6 now?
Yes. Sorry for the background noise. I have other people in this room as well.
It's fine. I've heard worse things.
Really?
Like baby crying, dog barking.
Really?
Yeah, 6.
They left.
62. 62. Mark scheme. Where is it? Here. Okay. Yeah. 62. That's a mark scheme. measurement and torque. Investigate the balancing of the meter rule apparatus. The then places the meter rule and the pivot at 50 centimeter mark in the middle, right in the middle. So places object P with its center on the meter rule at 10 centimeter mark, okay, from this edge on the left. The object covers the scale marking on the meter rule as shown in the figure. Explain briefly how to place the object P as accurately as possible with its center at the 10 centimeter mark. You may add to the figure or draw another diagram to help your explanation. You may, which means you don't have to do that if you are confident about your explanation.
Oh, no.
So we need to determine the middle, the center of this object. If it is a small object, we can use a caliper to measure the length, the length of it, and then divide and use a marking pen to determine the middle position of this object on the both sides, and then draw a line connecting them to determine the middle point, the center of mass of this object.
Yes.
Yeah. And mark, use the pen to mark that position, and then ensure that you can put that right at the 10 mark on the ruler. So let's see what does it say in the mark scheme here. Explain diagram showing equal readings either side of 10 centimeter mark or average reading either side of the mark. Okay, as I understand this mark scheme, it is like it is 10, so you need to add a and subtract a, with a is half of the length of this object.
Yes.
So as long as you have two values, for example here 12 and here is 8, each edge of this object is at a location at a mark which is at the same distance to the middle mark 10, then it is accurately placed at 10. Okay, so and you don't always have a caliper to use because it's the only available in some laboratory, not normal homes. Okay, so place the edges, the two edges of the object so that the differences from those edges to the 10 centimeter mark is the same. You can use another example to clarify that. One edge is at 8 centimeter and the other edge is at 12.
Yes.
It's only one mark, so don't worry too much about drawing a diagram.
Yeah.
Okay. The next one, question B, the student places object Q on the meter rule and adjusts its position until the meter rule is as close to balancing as possible. C records the distance A equal 40 centimeters between the center of the object P and the pivot. Okay, this is A 40 centimeter. The center of the object Q at the 71.2 mark. Determine and record in the table the distance B between the center of the object Q and the pivot. Okay, determine B. Show your working. Okay. In the table, where's the table? Here. Okay, you need to write B here. Can you do that yourself?
Yes.
Let me send you the link to the website here, so that you can download the paper, any paper you like, basically present made. Writing the clockwise moment, which is, what is the weight of P? Do we know the weight of the object P? No. Are P and Q weight the same? I don't think so. They didn't say anything about the weights of P and Q. Oh, the weight is given in the table below. No.
Oh.
P.
No.
No. There's no information about their weights.
Mm.
40 centimeter, the mark distance CB. Okay, so the distance CB is simply no calculation about the torque. You simply just subtract here. You simply subtract 71.2 from 50 because the pivot is at 50 here. Okay, and the center of Q is at 71.2 here, center. So we simply subtract 71.2 by 50. That is 21.2. Show your work. Just show it here. 71.2 minus 50. 21.2 centimeter. Plot the graph. No need to start your graph from the origin. Okay. Because do you have a printer at home?
Yes.
Probably you want to print this graphing paper, yeah, and do the graphing on this. Yeah, take your time. Hit the printing button. This. Have you found the paper 662 here?
Oh, I'm not at home right now, so I don't have a printer right now.
Okay.
Yes.
It is kind of late at night. Where are you now?
Oh, I'm in a cafe. Study cafe.
Do you usually get home late?
Not quite.
Okay. A 40 centimeter B. Plot graph of A on the vertical axis and B on the horizontal axis. So the maximum value is 40. We can choose here 10, 20, 30, and here 40. Okay, for A. The unit is centimeter, and B also, of course, centimeter. And the maximum value of B is 21. So here's 5, 10, 15, 20. Okay, so we need to determine 21, 15, 16 here, 17, 18, 19, meaning two tiny square represent 1. Okay, 21.2 is a little bit 21.2. We should like get yeah, that is too tiny to represent 0.2, 0.2 or 0.1, because each square here represent 0.5, each tiny square here represent 0.5, right? 1 here, 2, 3, yeah, so each square represent 0.5. So 21.2 is difficult to, this is 21, 0.2 is here. Okay, and A is 40, so that is 21 here, 21.2 here, this point, okay, this point, the first point. 35 and 17.8, 17.8 very close to 18, which is here, and 35 right in the middle here, huh? Okay, 35, 18 this side, huh? Okay, this is the second point. Okay, because the poise, the value is like 0.1, 0.2, and therefore the dot must be as tiny as possible, huh? The most is half of the square, huh? Okay. Oh, I lost one mark. 18, 18, 35, 18 here, up here, 35 here. Okay. The next point, 15.1, 15 right here, 30, so it cannot be a little bit to the right, huh? Right here, next point. 25, 12.3, 11 here, 12 here, 12.3 here, 25, yeah, 25 here. Okay, another point here. So they form a beautiful straight line, huh? But there's no tool to draw a straight line here on this tablet. Wait, let me try putting a ruler on the board. There's no way to draw it, huh? Okay, the last point, 29.7, almost 10, 20 here, almost 10 here. So this is the next point. Okay, so oops. Okay, so the point is that they will form a beautiful and straight line, huh? Okay, that's probably the best that I can do. Determine the gradient. If it is not good enough, then my calculation of the gradient will be totally a mess, huh? Okay.
Yeah.
Gradient. Okay, so I will try one more time. Or I can copy this to another software and use a ruler to draw a line. Yeah, it will be better. Let me copy it to a pen. Okay, now drawing a line through these points much simpler, huh? You know, not necessarily to all the points, but we see the best. Okay, now calculating the gradient. Okay, the gradient. Choose any point on that line so that the value is easy to read, huh? For example, I choose this point to be 40 for the rise, huh? And another point here, 20, 40 minus 20, and the run is at 40 here. The value is 21. A little bit greater than 21, but doesn't matter, it's 21. Okay, and the other point here is 9.5, huh? 9.5. So the gradient is this ratio, 20 divide 21 minus 9.5. It is 1.74. 1.74 radian. Okay, let's check the mark scheme. question 1D, huh?
Yeah.
From 1.6 to 1.9. Oh, you have a wide
Oh.
range of acceptable values, huh? Beautiful. So
Mm.
feel free, feel relaxed to draw the line. Yeah.
Mm.
My result is 1.7. Yeah. You know, two significant figures, not three.
Yeah.
Okay. So the
Yes.
gradients in my calculation is 40 minus 20 over 21 minus 9.5 and round it to 1.7. The gradient, oops,
Ooh, was a good one.
acceptable. The gradient of the graph is equal to the ratio of the mass P and Q, equal to the ratio of the masses P and Q. Okay, record the ratio R of the masses P and Q. Ratio R of the mass P and Q gives the answer to several number of significant figures for the experiment. Ratio, gradient is the ratio. The gradient I calculated is 1.7. So what is this answer? This question? Ratio of the mass P and Q. So the answer for R here is the same, 1.7. Okay, answer, huh? G, R equal G, okay. R equal G, so yeah, the same answer. Given to two or three significant figures, so we are allowed to take three significant figures. 1.74, okay. Three significant figure allowed. Yeah, because here you have three significant figures.
Oh, yes.
Yeah. Okay, that's it. Question about graphing, calculating gradient. This is about electricity. We will skip. Lens, electric heater. Okay, that's it.
Oh.
That's it for paper 1. Paper 6. Only one question about, yeah. Moment. Okay, I think we can return to question 2 again. And now 2-1 instead of 2-2 last time.
Yes.
All of these paper that I wrote on is saved on one folder here, and I will make a online folder and put all of them in there, like other students you see here.
Okay.
Yeah. I'm doing it now. A new folder of yours. Okay. After finishing writing on this document, I will move the document there. Here. Download again. Yeah, you see the new one. So, and mark scheme 2-1. Here. Wait, it is the same. The same with the 2-2, huh?
Yes.
Just a little bit different. So we should move to another year, last year, yeah. Instead of this 2020 years. October, yes, probably. February, okay, we can do February. And ask you here also. May, March. What's that? Probably this one. Okay. A student investigated a pendulum. He measured the time of the pendulum to complete 20 oscillations. He repeats the experiment 3 more times. The reading is shown. What's the average period of the pendulum?
Okay, 1 second.
20 oscillations. So firstly, you need to divide. Okay, there are 2 ways to do that. Firstly, divide each number here by 20 and then add the results and then divide 4. The second way is adding all these results, divide 4, and finally divide 20.
Oh, okay.
Meaning, okay, 17.6 plus 19.8 plus 17.6 plus 18.6, all divide 4 because we do 4 experiments, okay, and then also divide 20 because this is the time for 20 oscillation, not one single oscillation, okay, so you have to divide for 20.
I got B.
D or B? D.
Oh,
Wait,
B.
B, yeah. Cannot be D because that is too big, yeah. So,
Yes.
yes, definitely B, yeah.
Mm.
The tennis ball falls from the upstairs window house. What can be said about the acceleration of the ball if a resistance is ignored?
I think it stays constant.
Yes, the same, which is 9.8. That free fall meter per second square. A car joins a road at a speed of 14 meters per second and accelerates at 4 meters per second squared for 5 seconds. What is the final speed of the car?
Okay.
V equal U plus AT. U, the initial speed is 14. Okay, acceleration is 4 and time is 5. So that 20 plus 14, 34.
Okay.
Initial speed
Mm.
U AT. The gravitational field strength 8.8 Newton per kilogram on Venus and 3.8 Newton per kilogram on Mars. Object weight 42 Newton on Venus. What the mass and the weight of the object on Mars? 88 Newton per kilogram, the field strength. So firstly we take 42 on Venus, divide 8.8, like 40 divide 9, it's about 5, meaning this one, so we eliminate these things. On Mars it is 3.8 compared to 8.8, so it is about a half, less than a half, therefore the weight will be about a half, less than a half, which is 18. Cannot be 42, the same as Venus, so that is definitely A. We don't need to do the calculation, we just need to estimate. Okay? Yeah, estimate. A student carries out an experiment to find the density of rock. Which 2 measurements does the student need to take to make to determine the density of the rock? Density
The increase in
is mass over volume, huh? We got the increase in the mass, which is 64 kilogram. 64 kilogram is the mass of the rock, and we also need the increase in the volume, which is volume, the rock. So the answer, measurement 1 is the increase in mass, and measurement 2 is the increase in the volume. Answer A. Question 5.
Yes.
Yes, that's A. Question 6. A car has a mass of 1,500 kilogram. A constant resultant force acts on the car, and the car accelerates from 15 to 20 meters per second in 4 seconds. What the magnitude of the resultant force acting on the car?
Oh, okay. Okay.
How do you do that? Resultant force, mass multiplied with acceleration. Mass is 1,500. We have to calculate acceleration, which is 20 minus 15 over 4. 4 is the time. Yeah, the time. 20 minus 15 is the increase in velocity given here from 15 to 20. Yeah, so this is 5 over 4.
Yes.
Can we estimate that? 5 over 4 multiply with 15,000, 250 multiply with 5, 1,200, about this, huh?
Oh, wait, oh yeah.
Wait. It must be greater because 5 over 4 is greater than 1.
Yeah. I think it's C.
Yeah, you see. This is wrong, sorry. But yeah, definitely C. Evens. A metal Y is loaded up to the limit of proportionality. Which statement is correct?
I think it's D.
Up to the limit of proportionality, there is no change in the shape of the Y. No change? The limit of proportionality over this limit, the object cannot restore the initial shape and size. Okay, Hooke's law is not obeyed when the law is increased from 0 to this point. It is wrong because it will be obeyed the Hooke's law during the first tiny increase extension of the Y. The law increase beyond the limit of proportionality, the diameter of the Y will increase. Wrong. Not obey, wrong. The law is removed, the Y return, wrong. Yeah, so that could be very likely to be D. 7C. Wow.
Oh, is it because it hasn't reached the proportional thing yet? The limit.
Loaded up to the limit. Is loaded up to the limit. Up to, but not yet over, huh?
Oh,
yeah, not over.
okay.
Not over. Not over, so it can return, yeah. It can return. Yeah. A and B are definitely wrong.
Yeah.
The diagram shows uniformity rule MN pivoted at its middle point P. The two ways W1, W2 hung either side of the pivot. The rule remains balanced. Which row is correct?
If it's balanced, it's 0.
Movement 0. and resultant force also is 0. Okay? Answer D.
Mm.
Here are the two conditions for an object to be in equilibrium, balance. Both things, force, resultant force and resultant moment, are 0. Which physical quantity is a vector? Very easy, huh? Velocity. Resultant force, 500 newtons, acts on for 10 seconds on a car mass 1000 kilograms. This causes the velocity of the car to double. What defines the velocity of the car? 10 seconds. Think about it. 2 minutes.
Oh, okay. Oh wait, am I supposed to solve this question? I don't know. I was in the process of doing it. I was confused. Anyways,
Okay.
yes. Give me a
500
second to get
newtons.
this.
So we have the resultant force and the mass here. So we can calculate acceleration, huh?
Yes.
Net force divide mass, 500 over 1000. So that 0.5 meter per second. The velocity is double, which call the initial velocity is like x or v, just v, okay, and then double meaning 2v. So the increase in velocity is v 2v minus v, which is v over the time 10 seconds, and that acceleration is 0.5. Therefore, velocity is 10 times 0.5, 5 meters per second. Okay.
Mm-hmm. Okay.
So what were you doing?
Oh, I thought you were gone. I was like, I thought you were doing a break. I was waiting for you.
Yeah, we can take a break later. Next time, after about 45 or 50 minutes. But it is
okay.
like almost the end of the session, so I cannot like give a break right now. Okay. You got it? From V to
Yes.
double the speed. So basically, change in speed divide time is acceleration. A child pushes a toy car along with horizontal surface and then releases it. The car slows down. What is the main energy transfer? We don't need to do that, but slow down, energy transfer from kinetic to thermal.
Oh, okay.
At the time 0, a cannonball stationary inside a cannon. The cannonball then fire from the cannon. At the time t, the cannonball moves forward and the cannons moves backwards. What happens to the total kinetic energy and total momentum of the cannon and the cannonball between the time 0 and t? Total kinetic energy of the cannon and cannonball after firing definitely changes. Kinetic energy cannot be the same. Momentum the same. So the answer is here. Question 12. B, yeah. The momentum is always the same in the two types of phenomena, that is collisions and explosion, with one condition. Explosion with one condition is that the system is closed, meaning the interaction of the object in the system with the outside, with the surrounding, is negligible, or you have to apply the conservation rule in a very short time, extremely short time, during the collision and explosion, so that the energy and the momentum didn't have enough time to transfer from the system to the surrounding. The instant right before collision and right after collision, like the two balls hitting each other and bounces off each other, but after leaving each other at a distance, a part of their energy and momentum, of course, will transfer to the ground. Okay, so the point is that you can only apply the conservation of momentum in extremely short time, right before and right after collision. Okay?
Yes.
Efficiency, energy, skip. Horizontal surface lubrication, use a calculated pressure.
No.